Hello everyone. So today we will be talking about the domain name system, which is DNS. So this is a very comprehensive guide, and there are a lot of terminologies which you might have heard for the first time. And try to watch this video 2 to 3 times because there are concepts which are interrelated. And when you will like join those pieces, those puzzles, those concepts together, right? Then everything will make sense. Okay, I will try to keep it as simple as possible. So let's see the diagram first. Okay, let's suppose you want to register, you bought a new domain example.com. Okay, so you registered at GoDaddy or AWS Route 53. Okay, so when you're registering it, an IP address needs to be allocated to it, right? And this information needs to be stored that example.com has this IP address. Okay, so what AWS Route 53 internally does is it assigns the name server to this domain name. Okay, so what it does is it's like this is some server which they call the authoritative name server. Okay, authoritative because it will be storing your record example.com and corresponding IP address, which is let's suppose 192.168.1.1. Okay, so it has stored this in a zone file on their server. Okay, this is the server which is owned by this AWS Route 53. Similarly, there can be other servers which are owned by GoDaddy, okay, or by any other provider, okay. So once this is registered, right, by AWS Route 53, now it is their own server. Now they need to tell the world that okay, there is new domain which is registered and corresponding to this is the IP. So you can reach us over here. So to whom will they tell? They will tell this to the TLD registry. Okay, this is managed by the organization name VeriSign, or there are other like there are many TLD registries, PIR, VeriSign. Okay, so they update this record, their name server record. Okay, they say that if example.com comes, you just go over here to this authoritative name server. Okay, so this registry then updates it to their servers. Okay, TLD name servers. So what are TLD name servers? Like you must have heard, right? Google.com, okay, or some website example.in, okay. So for .com there is a separate name server. For .in there are separate name servers. Okay, .com stores all the host names corresponding to this .com. Okay, all the name servers corresponding to this .com. Similarly, .in stores all the name servers. So whenever the request will come to this TLD name server, it will know to which authoritative name server does the zone file contains, does the actual IP contains, and the host name. This host name IP mapping is present on this server. Okay, so TLD comes to know through TLD registry. TLD registry comes to know through the AWS Route 53, and AWS Route 53 have their own authoritative name server. Okay, and this TLD name server is kind of a recursive server because it doesn't own any record. It has to reach to the authoritative name server in order to know what's the corresponding IP address for that domain name. Okay, so this is from your perspective when you buy the example.com, right? What happens internally by them? Okay, so once all these records are updated, right, as you can see over here, now let's see what happens when a user type your domain name www.example.com in a Chrome browser. So when they type www.example.com in their Chrome browser, so first of all, the browser checks it in its own cache, right? The developers of the Chrome or developers of any browser which you are using have written their software in such a way that first it checks the cache of that browser. If it is present in cache, it simply returns from there. Okay, it gives the result. But if it is not present in the cache, so it checks the operating system level cache. Okay, how it checks it, we will deep dive into it. We will deep dive into every component we talked here. We will deep dive into zone files. We will deep dive into TLD registries, everything. So if the cache is not present in the operating system, then what will happen? The operating system will go to the your internet service provider. Let's suppose it is Airtel or any other internet service provider. So they have a recursive resolver. Recursive resolver means it doesn't hold the record. It is responsible for recursively fetching from different from different servers. Okay, so this your DNS like ISP first check it's in its own cache. If it is not able to find its in its own cache, it asks the root name server first. So there are total 13 root name servers in the world. Okay, we will talk about it in more detail. And these root name servers tell to which TLD name server to reach out. Okay, so it gives the information of the TLD name server. So we then reach to the TLD name server, say .com, which contains the .com. Okay, then it returns the address of the name server, authoritative name server. In this case, it was Amazon's, like AWS authoritative name server. Now we go over here. Okay, so there is a software which runs, generally Bind software. Bind is the name of the software. We will read about it in more detail. What it does is it checks the zone file. Okay, zone file was updated here, remember? And it checks the zone file. It sees, okay, there is a mapping. It returns the DNS record. Okay, and over here, the ISP recursive resolver caches it, returns to OS. OS caches it, return to browser. Browser caches it, returns it to the user. Okay, so this is the complete flow. And now if you have not understood, right, like I have used so many terminologies over here, no need to worry, we will deep dive into it in more details. So what's the summary? So first of all, user will request a domain. When you will type example.com in the browser, your computer needs to find the corresponding IP address, so it will check the local cache. If it is not able to find it, it will query the ISP DNS server. If it is not able to find it, the request goes to the recursive resolver. Like first the root name server. If the root name server, like any of the 13 root name servers, okay, it will check that where to go. It will reroute to the TLD name server. TLD name server will then reroute to the authoritative name server. Authoritative name server contains the actual address. Okay, it can be of any, like it can be of AWS Route 53, GoDaddy, anything. Okay, and the IP address returns and website gets loaded. Okay, because name itself doesn't have any meaning, the IP address has the meaning. Okay, so let's talk about what are root DNS servers, which we talked here, right? What are this? Okay. So the root DNS servers are the highest level of DNS. Okay. So they hold records for the TLD that we seen. Like they hold records for .com, .org, .net. Okay. There are total 13 root DNS servers named A2M. A2M. There are total 13 root DNS servers, and 13 DNS server doesn't mean that there are total 13 servers. There can be many instances of one server. Okay, basically anycasting is used. Anycasting, we will see what is anycasting. Anycasting, you can say that one IP address is allocated to multiple instances. Okay, that is what any casting means. So although it is written a root, but it can have multiple instances. Okay, this is done to improve the performance and reliability. Okay, you are sitting in India, you are sitting in US, so there can be different servers near to you. Okay, and each root server is operated by the different operator. Okay, it is operated by ACAN, B root server is operated by this. So there are different operators for different root servers. Okay, so you might like think that these root servers, right, they can be misused by these operators, right? They can be misused, but if you will see, so a single entity doesn't control all the root servers. Okay, root servers are decentralized across multiple independent organizations. So you cannot say that US government controls all of them or ICANN controls all of them. Okay, so second misuse can be that whatever the root zone files are there, right, they can be tampered with. Okay, so the root zone file is managed by ICANN. Okay, so and it must be approved by multiple global stakeholders. So it's not so easy to, like, it is possible, definitely possible. Okay, but it is managed by ICANN. It must be approved by the global stakeholders. Third is the government interference. Government can easily alter the DNS records. Okay, but it's not, again, very easy to alternate the root DNS records because they are operated by different organizations across different world. If all organizations come together, then only it's possible. Okay, so but government can still block the DNS query. Like they can tell your Airtel or BSNL or different providers that block it at the ISP level only, like the China's Great Firewall. Okay. So there are different security measures also to prevent this abuse. One is the DNSSEC. We will read about it in more detail. What it does is it ensures that the root DNS responses cannot be forced. Okay, and there are multiple backups can be there. Like if few root servers goes down, DNS will still work because there is a backup server. Okay. Anycast routing is there. That is, there are servers closest to you. Okay. So you don't, like, your request doesn't need to route to US server. It will be routed to the closest root server which is present. Okay. And ICANN, which is a organization, it ensures transparency whenever it updates the root zone. Okay. So next is the top level domains. Okay, what are TLDs or the top level domain? It is the last part of the domain name, like .com, .org, .net. Okay, so these again are managed by different organizations. So it is these are supervised by ICANN. Okay, so ICANN doesn't own any of these TLDs. Okay, but they delegate it to the private companies or government agencies. So each TLD is operated by a registry, okay, which manages domain registrations for the TLD. For example, for .com, the registry operator is VeriSign. For .net, registry operator is VeriSign again. Okay, so for .in, it is the National Internet Exchange of India. Okay, so what are the types of TLDs? Like .com is for business, .net is for networks, .org is for non-profit, .in for India, .uk for UK, US for US, .gov for US government use only. Okay, .mil US military, .edu US accredited educational institutions. Okay, and some custom extensions present over here. So I used one word which is anycasting, right? What is anycasting? I already told you that it is a routing technique where multiple servers, right, share the same IP address, and the closest server will respond to the request. Okay, so instead of a single server having a single IP, so multiple servers will advertise the same IP across different locations. So when a user makes a request, the network routes the request to the nearest available server based on factors like latency, congestion, or hop count. So any casting, as you can see in the DNS world, right? So what happens is you query Google DNS. Okay, if you are in India, your request will go to Google's nearest DNS resolver. Okay, if you are in the US, the same 8.8.8, this is the Google's DNS resolver, right? So the same 8.8 resolves to the server in the US. Okay, so the same IP is associated with multiple server. One server is present in the US and the other server is present in India. Okay, so how Anycast helps? It helps in the speed, redundancy, and reliability, as you can see. Okay, whichever is nearest, it will go over there. So there are different terminologies like Anycast, Unicast, Multicast. There is a very slight difference. Unicast is one IP is associated with one server. Anycast is one IP can be associated with many servers, and only the nearest one will respond. Like if we are sitting in the US, the US one will respond. Okay, and multicast means one IP will be associated with multiple servers and all will respond in the video streaming or live broadcasts. Okay, so what are the type of DNS servers? So one is the recursive resolver, okay, which it performs DNS lookups and it then caches the response. Okay, it doesn't actually hold the actual DNS record. Okay, and second is the root name server, which we already talked. It directs the query to the TLD name server, and TLD name server directs the query to the authoritative name server. Okay, authoritative name server holds the actual DNS record. You just have to picture the first diagram which I show. You can take a printout of it and then watch the rest of the video, or take a screenshot of it, watch the rest of the video. You will understand it. Okay, where exactly this root name server was, where exactly the TLD name server was, where exactly the authoritative name server was, and what is the recursive resolver. Okay, so what are the types of DNS records? So there can be multiple types. Okay, DNS records store information about the domains. It can map a domain to a IPv4 address. It is a record. A record means maps a domain to an IPv6 address. Okay, so CNAME record means maps an alias to another domain. Okay, domain like name to name. Okay, MX record means specifies mail server for email delivery. TXT record means stores arbitrary text data often used for security. NS record means authoritative name server for a domain. PTR record means reverse lookup, right? So IP to domain. SRV record means specific server for specific service, example VoIP and XMPP. So these are the some common types which you might encounter in your real life. Okay. So there are some like primary DNS, secondary DNS server. So the primary DNS server is which holds the original DNS record. Okay. And secondary DNS server just act as a backup in case DNS server goes down. Okay. So it keeps on syncing the record from here. Okay. And forward and reverse DNS, reverse DNS differences. Forward DNS is from domain name, it will give us the IP address. Reverse DNS, which is our DNS, means from the IP address, it will give us the domain name. Okay. Now we will look into some like more detail into the DNS caching. How your browser interacts with the operating system DNS cache. So when you type in your browser www.example.com, it first check its own DNS cache. If not found, check the OS DNS resolver. In the OS also not found it, like if OS not if OS found, then it returns the result. If it is doesn't found, it goes to the DNS resolver. DNS resolver can be your internet service provider, or DNS resolver can be the Google's DNS. It depends. In your computer, right, you can specify that you should reach to my internet service provider's DNS, or you can reach to my Google DNS. Okay, there is a file, you can modify that, and then your request will be routed to that your ISP or to Google DNS or to any other DNS. Okay. After it receives the response, operating system will cache it, browser may cache it. Okay. So can the browsers bypass the operating system cache? Okay. So yes, the browsers can bypass the operating system cache. How? Using DNS over HTTPS. Okay. So if this DNS over HTTPS is enabled, so the operating system cache will be ignored and the queries will go directly to the DNS provider. Okay, example Cloudflare 1.1.1 or Google 8.8.8. Okay, so they support this DNS over HTTPS. So since it is over HTTPS, that means it comes with privacy and security, and it bypasses the local operating system caching. Okay. So how to clear each cache? To remove the Chrome cache or Firefox cache or Windows operating system cache, Linux operating system cache, Mac OS operating system cache. Okay, there are different commands to it. So you can see, right, at so many layers the caching is there. Okay, at the browser level, at the operating system level, and corresponding are the commands. So in future, right, if you ever face this issue that some site is not working, try to clear first the DNS cache. Maybe the site keeps on working, there is a corrupt entry in your DNS, or there is a stale entry in your cache, right? So try to clear it and then see. Okay, these are very important commands. So next we will read about the bind software. The bind software which was running on the authoritative name server. Check the diagram. Okay, you will come to know it was running on the its responsibility was to read the zone files. Okay. So what is bind? Bind is Berkeley Internet Name Domain. It is the most widely used DNS server software. If you have to build your own like DNS resolver also, right, you might end up installing this bind software. Okay, so what it will allow you is host your own DNS server. Okay, you can configure DNS records. You can implement a DNSSEC. Okay, just see the timeline when it was developed. It was developed in the 1980s, so it's so old and it works till now. That's the beauty of it. And how bind works? It runs as a DNS daemon. Okay, and what it does is whenever request comes, it processes the DNS query. How it processes it? It reads the zone file. It sees whether that name is present in the zone file. If that name is present in the zone file, it returns the IP address. So the type of DNS server bind can act as authoritative, like it can read the zone file, or recursive, it can fetch the answer from other DNS servers, or it can act as cache. Okay, so it will just cache the DNS response to speed up the query. So this is the configuration overview. In over here, etc/named.conf main configuration file with there, and over here it will store the zone records. Okay, so this is the example of the zone record, how it is stored. For example, .com like domain, how it goes. It stores the name server. It stores the corresponding IP addresses. Okay, it says that www.example.com. It maps to 192.168.1.100 over here. Okay, and NS records it declares over here. So next we will see the DNS zone file. Okay, what exactly is the DNS zone file and where it is stored? So the zone file can be stored directly on the authoritative name server which we saw. Okay, so the bind software, we saw that it stores the zone file directly as a text file. Or in order to improve the resiliency, like since we are now dealing with distributed servers, okay, there can be distributed databases. So the Route 53 or Cloudflare or Google Cloud DNS store DNS records in a distributed database across multiple data center. So they don't have like a single zone file on a server, okay, but they use a highly available replicated storage system, okay. So this is how the entry looks like in the zone file, okay. So this is the admin.example.com, okay, and it tells that what's the corresponding IP, what's the name servers for it, what is the TTL. TTL, if it is as less as possible, it is good. So now let's see how is the zone file distributed. So the zone file is distributed like traditional name servers. I already told you zone files are stored on primary and secondary servers. Secondary server get update from the primary via zone transfers. Okay, so we'll read about it in later slides. And one is the cloud-based DNS. So instead of single file, records are stored in a distributed database. So multiple authoritative name servers hold copies for redundancy. Whenever a DNS record is updated, so changes are propagated to all the authoritative servers. Okay. So now the question arises: does each authoritative name server have a copy? Yes. So in the traditional DNS, primary server has a zone file, okay, and secondary server syncs it via zone transfer. We will read about it, zone transfer, okay. In the cloud DNS provider, what happens is each DNS serves query from a distributed database rather than reading from a single file, okay. So there are some interesting tools which you need to know if you are dealing with DNS or generally IP addresses, okay. These are ping and NS lookup. So what is ping? What does ping internally do? It is simply used to test the connectivity between your device, okay, like if you're working on a Mac, okay, and the remote server, say www.google.com. So what it does is when you type ping space www.google.com in the command line, okay, so it sends the ICMP echo request packets, okay. So what happens is ping let's just to like if you will type www.google.com in your browser, right, so the internally ping gets called. Ping first queries the DNS resolver to get the IP address, okay. So second step is ICMP packet sending. So this ping sends small ICMP echo request packet to the target. Every packet has some sequence number and a timestamp so that it knows that this is the latency it took. So if the target is reachable, right, to which it is trying to reach, it replies with the ICMP echo reply. If there is no response, you will see that the request is timed out. Okay. So how the latency is calculated, like ping calculates the round trip time, like time took from your Mac to the server and server to your Mac. Okay. So if you will see over here, so we tried pinging, like we typed ping google.com and it tried pinging google.com, and here is some information replying from this bytes 32 time this TTL this. So time equal to 20 ms means time taken for the packet to travel, okay, how much time it took, and TTL means how many hops the packet has left before being discarded, okay. Second is the NS lookup. NS lookup, it queries the DNS server to resolve the domain name into IP addresses. So we simply type ns lookup space google.com. It asks the DNS server, whichever is configured, right, to resolve the domain. If the domain is in the local cache, like of your computer, it will result is immediately returned. Otherwise, it will ask your ISP DNS, otherwise then the root name server, then the TLD name server, then the authoritative name server. Then you will get the final IP address and it will be returned. Okay. So this is how it look like, ns lookup google.com, and this is what the answer will be, okay. Non-authoritative answer means that it is returned from the cache, okay. Difference between ping and ns lookup, you can see ping is just for testing the network connectivity to the server. NS lookup is related to the domain name, okay, domain for resolving the domain name to the IP address, okay. So the protocol used in ping is ICMP and the protocol used in NS lookup is domain name system DNS. So it only contacts the given IP, it not resolves the domain name. It queries DNS to resolve the domain name. It checks the network latency, ping, because it tells us the time, right? NS lookup doesn't. So ping can be used for connectivity issues. NS lookup is used for the DNS issues. So this is very important because sometimes people intermix those and sometimes they go in the wrong direction that, oh, it might be a DNS issue. Oh, it might be a connectivity issue. You need to know which tool to use when. Okay. Now we will look at some advanced information Okay, so when you type example.com in the browser, right, in your browser, so what the application, the browser will do is it will call the system resolver. Okay, first it will check the cache. Okay, in the cache doesn't found, then like in the browser level cache, it is not able to find it. It will call the system resolver via standard libraries. So what is the standard library? It is get addr info. This is a very important function. Okay, so this function first checks the local cache and then only queries the external DNS. It is responsible for finding the DNS like resolver, like where to reach out for DNS. Like how does it know where to reach out? Okay, so this is a standard POSIX function. It is written like this: get ADR info. It is used by applications to resolve domain name to IP address. glib is very famous GNUC library. Okay, it is very famous on Linux and WinSock on Windows. So this get ADDR info is used. Okay, so how does it work? It first checks like internal. If you will see the functions, right? If you want to see, you can see the code. So it checks the etc/host file for local entries. If it doesn't find over here, it checks the system level DNS cache. If it is not able to find there, it checks where to reach out, which DNS server to reach out, whether to reach out to the ISP DNS server or to 8.8.8, like this Google's DNS server, where to reach out. So it reads from here, it sends a UDP query or a TCP query. What's the difference between the two? We'll read about it. But it sends a DNS query of type either UDP or TCP to the DNS resolver. Then whatever response it is, it parses it, filters the result, okay, based on IPv4 or IPv6, and it returns a linked list of ADDR infrastructures. Okay, so that's how it works internally. So I talked about one term called DNSSEC. Okay, what's the full form of it? Domain Name System Security Extension. Okay, so it is a security extension to DNS. It prevents the DNS spoofing. Okay, so it ensures that DNS response is legitimate. So as you know that each DNS zone has a like public private key pair, and DNS records are digitally signed in this case. Okay, so in this case, each DNS zone has a public private key pair. DNS records are digitally signed. So whenever the resolver will query the DNS enabled domain, we need to enable it. Okay, it will check the signature with the public key. If the signature is missing, then the response will be rejected. So what's the difference in this? Just this digitally signed thing has come here extra. Okay, so DNS records are digitally signed. That's why it says DNSSEC, security extension. Downside is, since you are like signing it, you like extra computation is there, extra checking is there, right, at the runtime. So extra time will take, extra computational will take, DNS resolution might take more time. Okay, and DNS resolution is like this DNSSEC is not supported by not all resolvers. Okay, so this is a rare feature, not as rare as that, but still it is not supported by all resolvers. And why we use it? We use it so that the DNS like cache doesn't get poisoned. Okay, and it ensures the integrity, that responses cannot be modified in transit. Okay, since they are digitally signed. So next is DOH, which is DNS over HTTPS. So what is DNS over HTTPS? It is simply the DOH encrypts the DNS queries over HTTPS. Okay, so what's the benefit of encrypting over HTTPS? So no one will see like what's the DNS query, what is the DNS response. So instead of using the UDP, okay, so DOH queries are sent over HTTPS, which is port 443. Okay, so the browser or the operating system, it contacts the DOH compatible DNS resolver. First of all, DNS resolver need to be DOH compatible, and the DNS response is encrypted, and man in the middle attack, it gets prevented from there. Okay, so that no one spoofs in between. Okay, not spoofs, I mean no one sits in the middle and sees like what is the request or response. So why we use it? So to maintain privacy and security, so that our ISPs can't track like which website we are visiting, and for security, so that it prevents the DNS spoofing or eavesdropping. Okay, downside is some firewalls may block DOH. Okay, corporate networks may not support it. Okay, because they need to keep track of it. So users may not have control that which DOH resolver will be used. Okay, so DNS queries can be made over the UDP, or the DNS queries can be made over the TCP. Okay, so why mostly we see that DNS are made over the UDP? Because UDP has no connection setup. TCP needs a three-way handshake. It is costly. There is more overhead, but in UDP there is no overhead. Okay, for whatever small queries are there, UDP is responsible for that. Okay, because UDP's max max response fit should be within the 512 bytes. If you have so many responses, okay, corresponding to like say one domain, there are multiple IP addresses or whatever the case may be, the response is large, or multiple name servers. Okay, so whatever the case may be, so if it exceeds, right, then use TCP. TCP is good for larger responses. And in the zone transfer also, TCP is used because it maintains the reliability. Okay, we will read about zone transfer. What is the zone transfer? Why zone transfers are needed? Okay, but just to maintain the reliability, zone transfers are done using TCP, because in UDP it is not preferred because the data might get lost. So DNS over TLS. So for secure queries, DNS over TCP plus TLS is used. So this is the difference between UDP and TCP. UDP faster, TCP slower. UDP overhead low, TCP overhead high. UDP less reliable, TCP more reliable. UDP is easier to spoof, TCP is more secure. UDP has standard queries, TCP large responses only. In zone transfers or DNSSEC, it is used. Okay. So what are zone transfers? Simple. It is a mechanism used by DNS servers to synchronize records between the primary and secondary DNS servers. Okay. So there are two types: AXFR, which is a full zone transfer. It transfer entire zone file which was present, right, from one server to another. Okay. So in the incremental zone transfer, it transfer only the updates instead of the whole database. So why do we need this zone transfer, right? If you have a company like GoDaddy, so why do you need this zone transfer? So companies like GoDaddy, if they have multiple DNS servers, okay, so they need to ensure that all DNS server have the same records. This helps in load balancing and redundancy. Okay. So why they use TCP? Again, simple answer: reliability. It is more reliable. It is guaranteed. Okay, it can handle large zone transfers. Okay, that's why we use TCP. So that's what is written over here. So what's the difference now if you have to summarize? DNS over UDP, TCP, and DNS over HTTPS. Again, speed wise, fastest. UDP is fastest. Slower. Reliability, can lose packets. Both are reliable, TCP and HTTPS. Security wise, UDP is vulnerable. TCP is harder. This is harder to spoof, but HTTPS fully encrypted. Okay. Privacy wise, both UDP, TCP fully exposed to ISPs, but in case of HTTPS, it's hidden. Okay. So which is privacy wise, this is more secure. DNS over HTTPS. So next we will read about the DNS spoofing, which is cache poisoning. Okay. So it is used by attackers. Okay, what they do is they inject the false DNS record in the resolver cache. Okay, so what this leads to is, it leads that whenever someone will type www.google.com, it will not resolve to the actual IP address of Google. It will resolve to the IP address of the hacker. Okay, so the attacker will send the fake response to the recursive resolver. Okay, before the legitimate response arrives. So the resolver will think, okay, this is actual fake response is the actual response. Okay, I will cache it. So when the user will query that domain, okay, they will get to this fake IP, fake malicious website. Okay, how will you prevent it? You can use the DNSSEC. You can use the DOH/DOT. You can set short TTLs I explained earlier to reduce cache poisoning. Okay. So there can be DOS attack also, DNS servers. Okay, so that domain resolution gets disrupted. Okay, so one is the DNS amplification attack. Attacker, what it does is it spoofs the victim's IP, sends small DNS queries to resolvers. Then resolver replies with larger response. It overloads the victim's server. Okay, so like 100 byte query, 4000 byte response. Okay. So NX domain flood attack means the attacker sends massive request for the non-existent domain which doesn't exist only. The attacker will send the massive request. Now the resolver, it will get overloaded. Why? Because it will try to resolve and it will try to store the NX domain responses. Okay, whereas it is not existent. So how do you prevent it? Use rate limiting on DNS server so that DOS attack doesn't happen. Enable anycast. Anycast means we have to distribute the DNS load. Okay. Use the DOS resistant DNS providers, which is like Cloudflare, Google, pretty good companies, right? So, what is this NC domain attack? Okay, name collision attack. It happens when an internal domain name, okay, it intentionally conflicts with the real world public domain name. Let us suppose in your company, this is the domain name which is being used only in your company. There is no public record for it. Suddenly, I publicly register this. Okay, so what will happen is, let us suppose in your company you switched off the VPN. Now your request will start going to the actual public domain, right? So that way I will be able to see what you were searching for, or I may be able to see the credentials if you try to enter. Okay. So the internal system will leak traffic to external resolver. Attackers can register these domains and hijack internal traffic. Okay, so that's what is explained over here also of the example, like how this is being performed. How to prevent it? There are multiple ways of preventing it. We have to use the registered private TLDs. Okay, these ones. Ensure that internal DNS is properly configured, and we can block the unintended leaks via firewall rules, so that if someone tries to reach outside for this private, right, the firewall blocks it. So the company should have proper firewall rules set up for this custom internal domain name. Okay. So these are some of the points which you should know. I just compiled it, that DNS queries are sent over UDP or TCP generally, and network stack routes packet to the correct DNS server. And if the DNS over HTTPS is used, request is wrapped in the HTTPS. Okay. And the net filters, okay, the IP tables in your computer can intercept and block the DNS traffic. Okay. And EBF and XDP can be used for custom packet filtering at the kernel level. So if you are an engineer who have worked at the kernel level, you might be familiar with this. So load balancing using DNS. So there is approaches like round robin DNS, which distribute traffic across multiple IPs, or the geo DNS, which directs the user to the nearest server. And CDN and DNS integration. Okay, so there are CDNs like Cloudflare and Acme, where they use DNS to route traffic. Okay, and one is the split horizon DNS. So different DNS responses based on requester location. Okay. So what are the common DNS problems and their fixes? If your website is not loading, try this ping or NS lookup. Okay. Try to flush the cache. Okay. Or change the DNS resolver. Like if your resolver is pointing to your ISP, right? Change it to Google or Cloudflare. Okay. And how to improve the DNS performance? Instead of using your ISP DNS server, you can use the public DNS. Okay. Like for Google DNS, you can say the primary DNS 8.8.8, secondary DNS is this. For the Cloudflare DNS, you can change the primary DNS and secondary DNS on your local system, right? So yeah, for you can use the Open DNS as well. Generally, most people use Cloud DNS. Okay. And what are the DNS securities and attacks? I already told you common DNS vulnerabilities, NX domain attack, DOS attack on DNS servers, DNS spoofing, cache poisoning. We have already read it in detail. Security measures are DNSSEC, already read it. Anycast routing, already read it. Rate limiting. Okay. I hope this one is clear. This slide is clear. We already read about it. So one interesting question before we wrap up this video: how does your computer know where to reach out? Like where the ISP's DNS server is located? Like right now I am sitting in Delhi. I am connected to say my hotel's Wi-Fi. Then I go to Mumbai. Okay, there the ISP might be different, right? How will my computer know? Okay, so as soon as my computer connects to the network, right, Wi-Fi or Ethernet, it automatically gets the ISP's DNS server via this protocol DHCP. You might have heard about it in your computer network class in your universities. So step-by-step processes, whenever your Mac joins the network, it sends a request to the DHCP server. Okay, so DHCP response, it gives the IP address, subnet mask, gateway, DNS server. Okay, then your Mac uses the assigned DNS. The system automatically configures the received DNS server as the primary server. Got it? And how does Mac decide which DNS server to use? So first of all, the highest priority will be given if you have manually configured it. If you say that I want to use the DNS server, okay, it will ignore the ISP DNS. Okay, this is some settings which you can go over there. And second is from the ISP, the DHCP assigned, like the protocol, this protocol assigned, right? So if it is not set manually, it can go to the DHCP assigned DNS, your ISPs. Okay, it will see over there. Okay. Third priority is given to the local DNS cache. It will might check its local DNS cache before querying an external DNS server. Okay, so these are the fallbacks slash etc resolve.conf slash etc slash host file. Okay, if there are some custom static DNS entries, it will check over here. Okay, so that's it for this video. You can repeat it. Okay, you can see it again and again because there is so much of content over here. Lot of content we read about it. Okay, get addr info, ping, ns lookup. There are a lot of tools, bind, how zone file, dns zone files, bind works, how to clear the cache. Okay, primary DNS, type of DNS records, anycast, type of TLDs, name servers, root DNS servers, and this diagram, very important diagram. Okay, with this, I wrap this video. Thank you so much.